Today we will look into what is modified z-score and how it is used to detect outliers in data science, and I will explain it in a way that even a child can understand it easily. We will do an Excel demo first, then we'll write Python code. Let's begin. Let's look at this simple use case of doing study on people height. Here I have 7 different people with their heights, and the mean number or the average number is very simple sum of all these numbers divided by numbers count. So mean height or an average height of all these people will be 6.19. There is another concept called median. Median is just a middle number. When you sort all these heights, sorted list, and the middle number in that sorted list will be called median. Now, once you know what is mean and what is median, go to YouTube, search for code basic standard deviation. You will find 2 videos. In the first video, I have explained standard deviation, mean, absolute deviation. Second video, I have explained normal distribution and z-score. So watch that. And once you know those concepts, you can come back here and let's look at a different data set where I'm doing some property price analysis, and these are the property prices. And the analysis that I'm doing is I want to detect an outlier. Here 300k is an outlier. It's like an abnormally high value. See, in outliers is very subjective. In many cases, you want to consider this as a normal value. This is probably not an outlier. So based on case to case, you might want to treat these high value as normal values or outlier. Let's say here you want to treat it as an outlier. You can use mean as your basis, and mean, you can see in this screen, is impacted by these outliers. If you did not have these 3 outliers, this mean would shift somewhere here, where most of the data values are concentrated. But because of these high values, mean is shifted towards the right. And standard deviation is nothing but some boundaries around your mean. So one standard deviation, for a simple explanation would be some boundaries, left and right hand side boundaries around your mean. If you want to know the mathematics, go watch the other video. The usual practice is to use 3 standard deviation boundaries to detect outliers. Now here in this case, this 300k data point will come under the boundary. So your methodology will not detect this as an outlier. And the main reason this is happening is because mean has been affected by this high value. It has been shifted towards the right. What if for the same use case, now you use median? Median is just a middle number. So median doesn't get impacted that much by these high values. And what if you have, similar to standard deviation, you have similar kind of a median deviation? We call it median absolute deviation. And we will look at the mathematical formula, but it is just, it is similar to standard deviation, but it is using median instead of mean as its basis point. You can have 2 median absolute deviation. It is known as MAD in short form, 3 and so on. And the usual criteria for median absolute deviation is 3.5. I think that is a criteria for modified z-score. But let's say if you use this kind of methodology, what happens now is that this data point, 300k data point, is detected as an outlier. And the reason this is happening is we are using median, as a base, and median is not affected by these high values. The mathematical formula for MAD is you take every data point, subtract it from median of the entire series, take the absolute value and take a median of that. That is your MAD. And modified z-score is X is your single data point, because modified z-score is calculated for every single data point. So here X is that single data point minus median of X divided by MAD multiplied by 0.6745. Why 0.6745? I don't know. That's how the formula is derived. Now let's look at the Excel demo quickly. All right, here I have heights of every people. We'll first try to compute z-score. Okay, so z-score, the threshold is 3. So if anything is more than 3, you consider it as an outlier. So let's compute z-score. How do you do that? Well, first you find out the average, and average, the formula is average A2 to A8. So this is my average, and my standard deviation would be here, std dev p. So use p. There are p and s. P is for entire population, s is for sample population. So we'll use p. So we'll say A2 to A8. So that is your standard deviation. So std dev, and the z-score is nothing but the average height. So let me name these cells, and the way you name these cells is you say average height. So this is average height, and this is std dev. If you do that, this will name these cells, and here this will be this particular height minus average height. So you will say average height, or what is the name, average height. Okay, average height. So here you will do A2 minus average height divided by standard deviation, correct? So standard deviation. All right, so and then you can just apply the same formula on all these cells. And z-score, if z-score is greater than 3, then you consider them as an outlier. So here I will say, okay, is this greater than 3? No, false. None of these values are greater than 3, so this says there is no outlier. But look, people's height. There is no one whose height is 10 feet. This is clearly an outlier. But this methodology did not detect it as an outlier because this value had a lot of impact on average and standard deviation. Okay, so 5.2, 4.9, 4.5, all these heights are normal, but I think the highest person in the world was like 8 feet height or something, but 10 feet is just an outlier. So now let me use modified z-score for same, and let's see what it will tell us. So for modified z-score, if you look at our formula, first you need to calculate MAD, which is median of x minus median of x. Okay, so first let's find a median. So median would be, so median of E2 to E8, correct? So this is my median, and this one will be, so just doing some copy paste here, height minus median height. So okay, so let me name this cell and call it median height. Okay, and I will do this minus median height. Okay, and then we want to do absolute of that, so I will do ABS, which means if there's negative number it will make it positive. So apply the same formula for, so you drag this in little corner. Okay, and that is my height minus median height, and my modified z-score. So here I will put my modified z-score, but before I do that, okay, this is my median height, and this I need to calculate mean absolute deviation, and mean absolute deviation is nothing but a median of this colon this. So if you look at mean absolute deviation is median of all the absolute values x minus median xc. Okay, and the modified z-score formula is x minus median x divided by MAD 0.6745. So E2, so it will be E2 minus median height. So median height is, there is a named variable, so median height. Okay, and I want to name this one as well. This, let's say, let's call it MAD. So you are naming this cell, so it becomes easier to use it in a formula. And 0.6745 divided by MAD. Okay, you can just drag and drop. Amazing. You guys are awesome. You are expert in Excel. So now you calculated modified z-score, and the general guideline is to use 3.5 as a threshold for modified z-score. Anything that has a z-score, modified z-score of 3.5 or more is an outlier. So here you will do this. Is this greater than 3.5? No, this is not. But hey, we found this. See, now look at this cell. Look at this culprit, 4.3. Because this is more than 3.5, our methodology will say this is an outlier, and that is true. Height 10, 10 feet person, not possible. Therefore, in this particular case where there is an outlier, and especially, see, when your sample size is smaller, then this kind of outlier will have bigger impact on your average and standard deviation. So the general rule is, as such, there is no rule. You have to really try it out and see if z-score is better or modified z-score is better for outlier detection. But I have seen in my experience that if your sample size is smaller and if you have outliers, it will have more bigger impact on average and standard deviation. And using z-score often doesn't work. In this situation, if you use modified z-score, at least it will detect you, it will tell you a lot of, it will indicate a lot of big values to you, and you can maybe make a decision to exclude them as an outlier, or and or do a different kind of treatment for that outlier. Okay, now let's write Python code and let's work on a different data set. We will be using movies dataset for our analysis. I have downloaded this CSV file from Kaggle thanks to the contributor, and I have trimmed down this file because it had a lot of rows, and to demonstrate my concept I had to trim it down. So after trimming it down, my file looks something like this. I think it has around 100 or 101 data samples, or 50 actually. See, only 50 samples, and I loaded them into a pandas data frame. The way you do that is by running this command. Okay, so the file doesn't exist. So this is how you load this data set into pandas data frame, and you can see that it has couple of columns. So it has movie name, let's say Avatar movie. Okay, how much money Avatar movie generated? So I'll just display only 2 rows. So Avatar generated close to this much. Now this number is a big number, so I want to convert that number into millions of dollars so that it's easy to understand. So usually first I generally do describe on this revenue, and as you see, all these numbers are absolute numbers, so you definitely need to convert it into millions so that you get some good sense, you can consume that information properly. So I will create a new column, so I will say revenue in $1,000,000, and this is how in pandas you can add a new column, and that will be a transformation of existing column. So you take revenue, then you divide all the values by 10 raised to 6. So you will do apply lambda x divided by 1 2 3 4 5 6. And now when you do df dot revenue mln dot describe, this will show you the description of only that new column. And new column says, see, all the values are in million. You can also look at few rows in your data frame, and you will see that for Avatar movie, the revenue was this, but now you got this new column where it says 2787 million revenue. Avatar was a very successful movie. It earned close to $2 billion. So see, $2.7 billion. Fine. I got my revenue column now. Now the next thing I need to do is I will use z-score, regular z-score, to detect outlier. And to compute z-score, you need average value and you need standard deviation. And the way you can get that is, see, we already did it. When you do describe, you get mean value and you get standard deviation, which is here. So you can use some Python syntax. So let's say if you do this, you get this, correct? So the first value is count. So count, but you don't care about count. So in Python, you can do something like underscore. Second value is mean. You care about mean. So this will be return as tuple. So you can have a bunch of variables here for each of these, count, mean, standard deviation, and so on. So standard deviation, I will create a variable called std, and remaining variables, I can have underscore underscore, or I can just do this star underscore, which means I don't care. Underscore is used to store a variable for which you don't care. Very simple. And then once you do that, you can display mean and standard deviation. So mean is 187, standard deviation is 455. You get it. Now, okay, what we will do is we'll create a new column in data frame, which will be a z-score of revenue. And in order to do that, I need to write a function called get z-score. Okay. And I supply a value, then mean and standard deviation. And this will give me a z-score. Z-score formula is very simple. It is value minus mean divided by standard deviation. Z-score tells you how many standard deviation away your data point is. If you've seen previous video on z-score, you will get an idea. And the way we created this revenue column, same way we will create a z-score column. So we will say z-score is equal to def dot revenue in million dot apply lambda x. So this is a Python function that you're applying. You will say get z-score x, then mean and standard deviation you have here stored already. So now when you do df dot head, let's say 3 rows, what you get is, see, z-score. So this value is very high, that's why see z-score is higher, but you got this new column which has z-score. And now to detect outliers, it's super easy. All you do is you will say df dot z-score, whoever has more than 3 z-score is my outlier. So we get this Avatar movie which has 2.7 billion revenue. So we are doing analysis of revenue here, friends. So we are trying to detect outliers in terms of revenues. Now look, as I said before, this is a real number. It's not a data error. So based on your use case, you might not want to call this an outlier, although the value is bigger. But if it is queuing up the results of your rest of the data set, then yeah, fine. Remove this as an outlier. Now, other than Avatar movie, there are a couple of other movies as well which has bigger revenue. But because we are using z-score and because this revenue number is impacting the mean, we might not be detecting all potential high values. So now let's use modified z-score to compute this, or to detect the outliers. So first thing I will do is I will write a function to get median absolute deviation, and I will supply s. So s is a series or a number series, actually, the numpy series. and median is np dot median. So numpy module has this function method called np, which can detect your median. And we need to, if you look at our formula, friends, we need to find an absolute difference. See this absolute difference between x minus median of x. So x, what is x? S minus median. Okay. So x value in numpy, you can do the operation on the entire series, but this is an individual value minus median. So that is your diff. On the diff, you call median again. So you will call np dot median on the diff again. That is your MAD, and you return MAD. Okay. Now MAD, I will just compute MAD for df dot revenue in million. So see, this is what it is coming to be. All right. And then my median, because I need median as well. Median will be np dot median df dot revenue mln. So my median and MAD is this, and I need that in my modified z-score. So I will define a new function called get modified z-score. You supply a data point, a median, and MAD. See, modified z-score. What are the parameters you need? You need median, MAD, median, and the data point. So that's what we are doing here. And once you have that, it's 0.6745 into x minus median divided by MAD. Simple function, friends. I'm just translating this into Python code, this function. Okay, and just to test it out, if you want to know modified z-score of 2711, which is your avatar and median and MAD, you will find, see, very high. It was expected that the modified z-score will be very high for avatar. So avatar movie is 2787 million, right? So 2787, and it's 32. That's your modified z-score. So now let's create a new column called modified z-score. Same way, so you will do revenue in million and apply lambda x. You're just doing a transformation, and the transformation would be the function here, x, then median and MAD, and you will look at couple of rows in your data frame. And you'll notice at the end you will find modified z-score. Now compare z-score and modified z-score. When z-score is 5, modified z-score is 32. It is expected to be higher because you're using median as your basis. So now the general guideline is to use modified z-score of 3.5. So when I do that, I get a couple of more values. See, with z-score, I only got avatar, but now with modified z-score, I got Jurassic World and the Bodyguard. So Jurassic World had a revenue of 1513, $1.5 billion. That's big. And the Bodyguard had 411 million revenue. Now this you might not want to consider an outlier, but at least modified z-score is giving you more data points compared to normal z-score. And you can review these outliers individually and you can decide how you want to treat them. All right, so that's all I had. I'm going to provide a link of this code in the video description below. Just to summarize, we did an analysis of movie revenues, and we first use z-score to find out the outlier. We found only one outlier. Then we use modified z-score and we found 3 outliers. So based on a situation, using one or the other might be better. There is no clear guideline that you should be using modified z-score or just the z-score. You can use any. you have to look at your situation. If you have data distribution where you have less data points and there are outliers which are affecting your mean, then to detect outlier, if you use z-score, it's gonna be tough. In those situations, you can use modified z-score. All right, so try it out. The code link, everything is in video description below. And thank you for watching. If you like this video, please give it a thumbs up or share it with your friends. Thank you.